All right, so the first two say to plot the complex number and then find the absolute value. So on your test, you'll be given a coordinate grid, but on this you could have just plotted. So this would have been -3, 5, 1, 2, 3, up 1, 2, 3, 4, 5. Remember, it's just a coordinate point, so it stays as just that dot. And then the absolute value is the square root of a squared plus b squared. So I square root -3 squared plus 5 squared. I get the square root of 9 plus 25, which is the square root of 34. See if you can simplify that. This time you cannot. If this was on your test, then I would write it as SQRT inside the parentheses 34, no spaces. Number 2, I would go just down 5 places. And then absolute value, square root of 0 squared plus -5 squared, square root of 25, which brings me back to 5. Questions on either of those? Okay, then complex number in trig form. So this is the format it needs to be in at the end. R cosine theta, R parentheses, cosine theta plus I sine theta. R is the radius, so square root of a squared plus b squared. And then to find theta, we do inverse tangent of b over a. So for -5i, this would have been 0 and -5. My radius came from here. It's the same one as above, as number 2. So I already know my radius is 5. And then tan -1 of b over a would be -5 over 0. And I'm trying to find the inverse tangent of something that's undefined. Okay, so we can't use the calculator here because we want these to be exact. We want them to be in radians. If I go to my unit circle, which hopefully you'll have by then, and drawn on it would be all your tangents. When you do that, you should have at the bottom and the top is where it's undefined. And then because we plotted this already and it's at the bottom, I would know to pick theta as 3 pi over 2. So then my format is the radius, which is 5, times the cosine of 3 pi over 2, plus I times the sine at 3 pi over 2. That's what an answer would look like if it was like for those of you that are in person that you're writing on a line. If you're typing this in at home, this would be 5 parentheses cosine 3 pi for pi slash 2 plus I sine 3 pi for pi again slash 2. No spaces.
So why couldn't it be pi over 2?
Because it's when you plot that point, it's at the bottom. So remember, you have to plot it to see if it's the top or the bottom. There's always going to be 2 answers, but where it's plotted is going to tell you which one to pick. Yep.
Why'd you put tangent of -1?
Because it's really like the tangent of theta equals b over a. So when we solve it, we always tan -1 it.
Okay.
So I just skipped to that step. All right, then 4 says 1 plus I. So in coordinate point form, this would be 1, 1. If I was to plot that, I'd go right 1 and up 1. So I know I'm in my first quadrant. The radius would be the square root of 1 squared plus 1 squared, square root of 1 plus 1, or square root of 2, which can't be simplified, so it's going to stay as that. And then tan -1, this is my b, this is my a, 1 over 1, tan -1 of 1. When I look at my unit circle, there's going to be 2 tangents that have 1s. One is in the first quadrant and one is in the third quadrant. So I picked the one that's in the first quadrant because that's where the original point would lay, which means theta is pi over 4. So then I would write the answer as square root 2 parentheses cosine pi over 4 plus I sine pi over 4 if it was on a number line, okay, or open-ended. If it's on Canvas, we're going to write it as SQRT, open parentheses, close parentheses for the 2. Open the parentheses again, cosine pi slash 4 plus I sine pi slash 4, no spaces again. Yep.
Are we going to do it backwards or read on the
No. So the question just was, do we have to do it backwards? No, just to check it. If you had extra time, you could use that method. All right, questions on anything from the warm-up?
When do you like actually plug in the number?
So only if you're checking your answer on this one.
Okay.
So in the homework, it asks you to go backwards on one question, but on the test, it's just gonna give it to you like these. Yeah. You're gonna get one of each of these basically on your test. Plot it, find the absolute value, and then here it is in complex, find it in trig. So the plotting, remember there's two graphing questions on your test. They are numbers 1 and number 2. So folks from home, you'll need to print that answer sheet or get a blank sheet of paper to make it look like the answer sheet. I'll add that answer sheet onto the review assignment this morning so that you can print it. So everything on this, I kind of elaborated a little bit more than what I had written yesterday. Everything on this plus your unit circle with your tangents. Good morning, Jacob. Wait, did you just get me to know you're here? I'll zoom in section by section to kind of go over it, okay? But this is what's going to be covered. The problems will be on your review that's posted. So the first is law of sines. This was 6-1. Law of sines, the area of the oblique triangle. The law of sines is A over sine of A, B over sine of B, C over sine of C. The good news is you don't have to worry about a second triangle. There's just not enough time this time. So I took off the ambiguous case. It won't happen on your test. You'd never finished. So you'll get ones that are not ambiguous case, okay? And then the area of the oblique triangle, depending on what you're given, this is your side angle side. If you're given that information, you use 1/2 AB sine of C, 1/2 BC sine of A, 1/2 AC sine of B. You're going to get a word problem from either law of sines or law of cosines. And in those, you want to make sure you definitely review bearings. So the north, 30 degrees west, or south, 40 degrees east, that kind of stuff. So it will only be one triangle, law of sines, or one word problem, law of sines, and then you'll definitely get an area of the oblique triangle. Law of cosine, somewhere in your reference sheet, you want to screenshot those reference. That slide. So the first one is used for side angle side. The second one is used for side side. Again, same thing. You'll get one triangle for law of cosines. It will either be side angle side or side, or you'll get the word problem that will have that information. Also in 6-2 was Heron's formula. So A plus B plus C over 2 gives you S. You do not round that. If it has 3 decimal places, you keep all 3 decimal places. The test is actually going to ask you to tell me what your S is, and you'll get partial credit on that, and then it's going to tell you to find the area, and you'll get the other credit for that. So that's square root S times S minus A times S minus B times S minus C. Oh, there's no parentheses there. Okay, you want to be careful on those when you type them into your calculator. Remember, same thing for the alternate form. These have got to be grouped and grouped. Okay, that's where you get errors in your calculator. Oh. So that was all on the quiz. Again, your feedback for your quiz is open. You want to check that tonight so that if you have questions, you can ask. 6-3 is your vectors. So if I have an initial at x1, y1, and a terminal at x2, y2, I'm going to find CF means component form. The component form by doing x2 minus x1 and then y2 minus y1. The magnitude of that vector would be 2 ways. The distance formula, x2 minus x1 squared plus y2 minus y1 squared, all underneath that square root. Or if you already have the component form, the square root of a squared plus b squared. Then we did things like adding 2 vectors, subtracting 2 vectors, and multiplying by a scalar. To find a unit vector in the same direction of v, we do the component form of v over the magnitude of v. to find a vector in the same direction with a different magnitude, so I just said k because that's a scalar, but it could be any number there. You're going to do the unit vector like you just did. The unit vector comes from here. And then you're going to multiply that vector times the magnitude given at the end. Remember to look at your IJ format. If it gives it to you in IJ format, it needs to be given back in IJ format. Nick, we're reviewing for your test, sir. You might want to pay attention today. And then you're going to have the graphs of the sum and difference. So I'm going to give you a graph. If you are a person that's at home, you're actually going to have to take your paper and put it on top of your iPad and trace the lengths of U and V, because there's no other way to get them that accurate. Okay, and then you'll do whatever it says to do. U plus V, 7U minus V, whatever it is, and you're going to graph that. That's going to be question 1 and 2, that, and plot the complex number. Okay, then came dot product and angle between for 6-4. So given the actual component form of U and V, to find the dot product, we multiply the first two and add them to the product of the second two. The angle between, you want to do the cosine of the cosine -1, sorry, of the dot product in the top and over the product of the magnitudes. So be careful with this one because this is cosine. But then the B over A that we used for the problems in 6-5 is tangent. So just be careful there, don't mix those up, okay? And then if you're finding the component form given the magnitude and the angle formed with the x-axis, you do the magnitude times the cosine of theta, comma, the magnitude times the sine of theta. So you want that in not coordinate point form, but component form. And then the word problem here, so this is your other word problem. And that came with some sort of, like, it said it threw something up. I forget what the example was like they threw something, and there's a magnitude and then the angle it makes. And for those, you do the same thing as here. It's just you separate the answers out. It's going to literally say what's the horizontal and what's the vertical, and you'll separate those answers out. You don't put them in component form. And then trig form of a complex number is the last thing we did, and this is what was just on the warm-up. So you're going to graph the complex number. So this one I think is like actually number 2 on your test. For folks from home, it's in this order. For you guys, I think it's actually still in the natural order. That would be 2, and the graph 1 I think is like number 1 if you're taking it on Canvas. And then the square root of a squared plus b squared, and then the converting to complex that we just did. So it's r times the parentheses cosine of theta plus I. Ooh, that's not tangent. Change this, guys. So if I just airdrop that to you, this is sine. I knew there'd be something. Okay, r cosine of theta plus I sine theta. So again, if I just airdrop to you that, or if you took a screenshot from home, make sure you change that. And r is the square root of a squared plus b squared. And then to find theta, we do tan -1 of b over a. And remember, there's always 2 answers there. We base which one we pick on the initial plotted point. And then you definitely want your unit circle. Did I screenshot that yesterday? Of course I didn't. So I want my unit circle with the tangents written in. So tan here is 0, tan here is root 3 over 3, tan here is 1, root 3, undefined, negative root 3, negative 1, negative root 3 over 3, 0. And then just repeat it, negative root 3 over 3, no, sorry, not negative, in the third quadrant it's positive, root 3 over 3, 1, root 3, undefined, root 3. This time it's negative, negative 1, and negative root 3 over 3. So you definitely want it, I would say at minimum what you're looking at right now. That reference, but do not plan to have to dig through this. So like if you just took a screenshot and then you're like, I'll just look at it later, good luck, my friends. You will not finish. You need to know it so well. So if you're a person that learns from rewriting, rewrite it. Because you need to know it so well that you don't need it. It's just that you could check it for quick reference. I'm telling you right now, if you have to look back onto that reference sheet after every question, you'll never finish. There are 15 questions. Most of them are 6 points apiece. The big one, like a law of sine that has multiple parts, is 10 points. It will be labeled on your test. And then like the word problem was 8 points. And the ones where there's like 2 parts where you have to plot and also find the component form, that one's also 8 points. So there's a couple like that. Questions for me on format of your test? Oh, I don't think I put it on here. The orthogonal. I sure didn't. So remember, this is the dot product equals 0 or opposite reciprocals. Parallel. Same slope, same slope. Or again, neither, which means neither. Okay, those they're on your review. You would have known it was happening. That's the only multiple choice question. So it's going to give it to you as orthogonal, parallel, or neither. Everything else is open-ended. So either you're graphing it on your answer sheet or you're typing in your answers. The entire test has no spaces if you're typing in an answer. It has, like your square roots is SQRT. If it's got a pi in the answer, it's PI. The things that you've been doing before, we didn't have to do them in 6.1 and 6.2 because there was nothing like that. But the things that you did before will all be the same format. So this, if I just distribute the negative 6 in here, I end up getting negative 6 plus negative 6 root 3i. So it'd be negative 6 minus 6 root 3i. This is my A, so A is negative 6. This is my B. B is negative 6 root 3. So when I want to find R, well, first of all, I'd plot it, and it would be here, third quadrant, because you're going to go left and you're going to go down. And then this would be the square root of negative 6 squared plus negative 6 root 3 squared. So negative 6 squared is 36. And then you have to square this one and this one. So this is 36. And then the square root of 3 squared is 3. So that becomes 108. And then 144 underneath that square root. And that makes my radius 12. Then to find the theta, I have to do tangent of theta equals b over a. So tan theta would be negative 6 root 3 over negative 6. I get the tangent of theta equals just root 3. I go to my circle, and that happens again 2 places, up here at pi over 3 and down here at 4 pi over 3. And because I know my point is in that third quadrant, I pick the 4 pi over 3. So this answer would be 12 parentheses cosine 4 pi over 3 plus I sine 4 pi over 3. That answer your question? Lucy, are you good on the example, on the work?
Yeah, I got the tan number wrong. I don't know.
Okay. And Valerie, you figure it out?
I think so. Wait, so you just whenever there's a square root and then it gets squared, it just gets rid of the whole square root.
Yep.
Okay, thank you.
You're welcome. It's going to happen. Wait, this is the same question. I pulled in the same question twice. Hang on. Alright, this one was the other way around. So now it's already complex and it wants you to find it in coordinate point form. So what I want to do is, first of all, I can actually, this is like the check on the other ones that we did. I can actually find the cosine and the sine of 45. So if I had my unit circle in front of me, it'd be easy, but I also know that this is root 2 over 2 and root 2 over 2. So I'd get 5 times, the cosine there is root 2 over 2, plus I times the sine, also root 2 over 2. And then just distribute the 5 in, and I get 5 root 2 over 2 plus I times 5 root 2 over 2. And then we just put it in standard form order. So 5 root 2 over 2 plus 5 root 2 over 2. That would be in standard form. So you won't have to go in that order on your test, but you can use that to check your work. Okay, on your test you're going from trig form. No, you're going from complex into trig. This was trig into complex. Questions on that one? Yeah.
Yeah. So can you